To give the spinning propeller an impression of speed, you will use motion blur. If you missed out on the first movie, you can open the file p47 propeller prop speed.max to pick up from this point. With the help of the multiplier curve, the propeller now starts off slowly and then builds up speed. Select the propeller and isolate it. As you will learn in a moment, motion blur is computer intensive and is best handled separately. Render the scene. The background is still visible. To study the effect of motion blur, it is best to view the propeller against the light solid background. Go to the Environment and Effects dialog and switch off the background. Change the solid color to white or light gray. Render again. This is easier to read. If you want, switch to a perspective view and zoom in closer on the propeller. There are various motion blur effects that you can use in 3ds Max with different levels of quality. Some render relatively quickly but are of poor quality. Others can be adjusted for quality but take longer to render. Some work only with a scanline renderer, while others are optimized for mental ray. Here you will use a mental ray specific motion blur effect found in the Render dialog in the Renderer tab. In the Camera Effects rollout, enable motion blur. Notice the Blur All Objects option. This is significant as the effect by default applies to the whole scene. If you want to select specific objects to blur, you can then disable this mode. However, you then need to enable Object Motion Blur on specific objects by accessing their properties. If you render the scene between frames 0 and 20, you won't see any effect. The propeller is static, there's no motion, and therefore no motion blur. Go to about frame 65 and try again. This time, you can definitely see the effect. 3ds Max renders the before and after frames and superimposes them together. Let's take a look at some of the parameters. The shutter duration is arguably the most important value. It controls the amount of motion blur by keeping a virtual camera shutter open for processing. Practically, it defines how many before and after frames 3ds Max should render for the blur effect. The higher the value, the greater the effect. Set it to 1 and render again. Notice the blur effect on the propeller. The shutter offset value sets the beginning of the motion blur effect relative to the current frame. When the offset value is at 0, the blur is happening after the current frame. When the offset has a negative value equal to the shutter speed, the blur effect is happening before the current frame. If you keep the offset to a negative value equal half the shutter speed, it centers the blurring effect to the propeller blades. Currently, the motion blur effect is not great, as the quality seems to suffer. You can improve the quality by increasing the time samples. This also increases render time. Notice the linear interpolation at the tip of the blades. This doesn't look too realistic. Increase the motion segments value and try again. Keep in mind that this also increases render time. What took a couple of seconds to render on this system a few moments ago is now taking 11 seconds. Worse, if you enable the background in the rendering and exit isolate mode, you'll notice that a single animation frame is taking a long time to render. In this case, the render time is over a minute compared to a few seconds without motion blur. The render time would really suffer if you use motion blur for all objects in the scene, although most objects are static. The same scene is now taking almost 5 minutes to render, so you can see how useful it is to assign the effect at an object level. Make sure you set this value back accordingly. Another thing to consider is that motion blur parameters are not animatable. This makes it important to find the correct values to be used in situations where object velocity is not constant, as is the case here. Typically, you want to adjust shutter speed at a moment in time when object velocity is at its maximum. So far, you've only looked at frame 65 and adjusted shutter speed when the propeller is still gathering speed. At frame 90 or higher, when the propeller is already spinning at full speed, the motion blur is so extreme that you hardly see the propeller anymore. You may want to revert back to isolating the propeller against a white background. It will help see things better. Adjust the shutter speed and shutter offset values accordingly. In this case, values of 0.3 and minus 0.15 should be about right. Test it out again until you get an effect you like. The scene is now ready to render, but because of motion blur, expect a rendering time of 3 or 4 hours depending on your system. You can also check out the result by viewing the rendered animation you downloaded for this tutorial. Exit Isolate mode and then select the P47 In-Flight selection set. Click Yes to dismiss the warning. Switch the viewport to the Camera Fly viewpoint. In a case where the propeller is spinning at a constant speed, such as when the airplane is in flight, you may consider alternative methods to render the propeller. One practical way is to use an animated bitmap to simulate a spinning propeller. In the next 3 movies, you'll learn how to create such a bitmap using a variety of tools.